Hello everyone and welcome back. In today's video we're going to be exploring class 9 chapter 8 quadrilaterals. So let's begin. What are quadrilaterals? A closed figure with four sides, four angles and four vertices is a quadrilateral. So examples can be square, rectangle, rhombus, trapezium. So we know that a square is a part, a rectangle is a part, a rhombus is a part, and a trapezium is a part as well. So these are all quadrilaterals. Let's move on. The next thing we've got is angle sum properties of quadrilateral. Now we know the angle sum property of triangles, which is all angles sum up to be 180 degree. In this one, all angles sum up to be 360 degree. Now how do we prove that? If you've got these two triangles, so we have got this one and we've got this one, then how can we prove that they're like let's go back a little bit. Okay, so we have drawn a line in the middle of the rectangle at the diagonal, so we get triangle 1 and we get triangle 2. Alright, so how can we prove something from that? Now, in these two triangles, we know the angle sum property of triangles is that angle angle A plus angle B plus angle C is equal to 180 degree. Right? Now that will be is the same for both of these triangles. So 180 degree plus 180 degree is equal to 360 degree. So we have just proven that the angle sum property of quadrilaterals. Alright, some easy stuff we have got going on there. Just built on our prior knowledge. So let's move on. Properties of some shapes. Now in trapezium, one pair of parallel sides, so we've got this one and this one parallel. Parallelogram. What are the properties of parallelogram? We know that let me draw a better one. This is equal to this and this is equal to this. Alright, this is parallel to this is parallel to this. Easy. And if we've got A, B, C, D, then AB will be equal to CD, and BD will be equal to AC. Alright, so all sides are equal. Also, as well as all angles are equal as well. Actually, opposite angles are equal, as you can see. Alright, so opposite angles are equal, or sides are equal, opposite parallel sides, and opposite sides are equal. Not all sides are equal. Alright. So let's move on. The next one is rectangles. What's in rectangle? So we know that this will be equal to this and this will be equal to this. Easy. Now this one will be parallel to that, but this one will be parallel to that. All angles are 90, meaning they're all equal to each other. So what's the difference? In a parallelogram, you've got these two are equal and these two are equal. So these two are equal, but these two are equal together. But in this one, we've got all angles are equal. Alright, let's move on. The next one is a square. In a square, all four sides are equal, opposite sides are parallel, and all angles are 90. Easy to understand. We've got a little illustration of that right there. Then we've got rhombus. All four sides are equal. Just like a square, we've got all four sides are equal. Opposite sides are parallel. Opposite angles are equal. So it doesn't always have to be equal. It can be like that as well. Right? It can be like a diamond. So these two can be equal and these two will be equal to each other. Alright. The next one we've got, the last one. Diagonals intersect each other in the center at 90 degrees. So if you've got that, these will form 90, 190 each. Alright. Then we've got kite, two adjacent sides are equal. So if you have a kite like that, I know that's not a kite, that's a rhombus more, but still, these two sides will be equal together because they share this angle, so they're going to be adjacent, and these two will be equal to each other. They share this one, so they're going to be adjacent. Alright, these will be adjacent as well, but they're not going to be equal. Alright, just as you can see in the figure here. Then we've got Theorem 8.1. The diagonal of a parallelogram will divide the shape into two congruent triangles. So easy. You've got this, you've got that diagonal. Now this triangle 1 will be triangle 2. Now triangle 1 will be congruent to triangle 2. Alright, easy. Also that this will be parallel to that. So you can write it like DC. So this sign is for to say that these two are parallel, and this is for congruence. Alright, the next one is Theorem 8.2. In a parallelogram, the opposite sides will be equal. We have learned that how a parallelogram is. Then we've got Theorem 8.3. If each pair of sides are equal in a quadrilateral, it's a parallelogram. So not like that. Let's put it like that. So if this is equal to that, and if these two are equal to that, then this is a parallelogram. Okay? Then in a parallelogram, opposite angles are equal. Opposite angles are equal. This will be equal to that, but this will be equal to that. Only these two will be equal to each other, and only these two will be equal to each other. Alright? Theorem 8.5 says, if in a quadrilateral opposite angles are equal, it's a parallelogram. So just the opposite of this. So if you've got that, if opposite angles are equal, then this is a parallelogram. Parallelogram. Okay? Let's rub a little bit out. Oop. Don't know, it's not working at the moment. Alright, now let's move on to Theorem 8.6. The diagonals of a parallelogram bisect each other, meaning if you have a parallelogram like that, the diagonals will bisect each other. Now what does bisect mean? If you have got these two lines, this line is bisecting this line, and so is this line bisecting this line. Now what does that mean? This line, if it cuts at the middle of this line, in the middle of this line, then it will be bisecting it. Okay, if this line is cutting this one on its middle, then that is bisecting as well. Okay, so that's bisecting a line. Then if the diagonals of a quadrilateral bisect each other, it's a parallelogram. So the same, just opposite. If you've got a quadrilateral like that, and these two bisect each other, it's a parallelogram. Or in this one, it's just saying a parallelogram has that property, not that if you have a quadrilateral then it will happen. Alright, Theorem 8.8. If a pair of sides are equal and parallel, it's a parallelogram. So if a pair of sides, so if this side is equal to this side, and if this side is equal to this side, and these two are parallel, then it will be a parallelogram. Alright. Then the midpoint theorem. What's the midpoint theorem? The line segment joined from midpoint of a side in a triangle is going to be parallel, and it is going to be the half of it too. So if we look at it closely, it says that if you have got a triangle like that and you've got two midpoints and a line segment is drawn, this and this will be parallel, and this one will be the half of this. So as you can see, I've got A, B, C, and we've got D and we've got E. So we are saying that BC is equal to half of D. Okay, understand? No, that's the opposite. BC is equal to 2DE. So meaning the double of this will be equal to BC. Alright? Then DE is parallel to BC. Parallel sign again. Let's move on. Now we have to prove that. Now how are we going to prove that? So let's zoom in a little bit. Now, look. If we extend this like so, we have this. Now we are constructing this triangle so that this side will be equal to this side. Alright, let's draw that a bit more neater over here. So we've got a triangle and we've got these two sides which are parallel. I mean joining together, and these two are parallel. We've got triangle A, B, C, D, E. Now we're going to be extending this. So we've got a DEF. Okay. So why have I done that? Now these two, we've got two triangles as you can see. Now these two triangles, we have to prove that they're congruent. So we are talking about a triangle ADE and triangle EFC. Now how can we prove that? We know that this point is in the middle of these two. So meaning these two are equal to each other. So we know that EC is equal to EA. Alright, we know that. Then we know that DE is equal to EF. So DE is equal to EF. So DE is equal to EF. Because again we constructed it like that. So we've got the midpoint. This is Y, and we constructed it like that. Then we just need one more thing in order to prove it. Well, these here, it's a vertical bisector. So these two angles are going to be equal. So we know that angle E of this triangle is equal to angle E of that triangle. So we can prove that triangle ADE is congruent to triangle EFC because of SAS. Now what is SAS? Remember from the triangle chapter we learned that if you've got two angles and you've got a side in the middle, and you've got two angles and you've got a side in the middle, if those two are equal, then the whole two triangles are going to be, what are they going to be? They're going to be congruent. So let's move on. We know that. Then actually I'll stop right here and we'll continue this in the next part because this is getting a little bit long. Alright, so stay tuned.